Okay, so let's resume our lecture, right? So we have finished LU3, and now today's lecture we're gonna discuss about LU4. It's not really a long LU, but it's just to give you like some introduction or basic understandings on what is meant by experimental design. Yeah, so it's more to some concepts in statistics or in designing your experiments. Okay, so if anything unclear, you just stop me at any time. Yeah, you just shout. Maybe sometimes I'm not really aware of your messages on chat box. Yeah. Okay. So EDU4 is about experimental design. So basically, this LU will introduce you some terminologies that you have to be aware of, because in statistics, and not just in statistics, in science, in doing research, yeah, you are going to refer to those terms a lot, yeah? Especially when you are doing your FYP later. So here we will give you like some overview about what to do. Like if let's say you want to start any experiment, you have to design your experiment. So you cannot just start blindly. You cannot just start without planning. Yeah. So planning is the prerequisite for any experiment or for any research, not just in science. If you're like say social scientists as well, you have to plan. If let's say you want to do a survey, you have to plan. For example, like you have to know what are your samples, how to do it, and what parameters you are looking at. Yeah? So those things are quite common sense like in research, and you have to plan your stuff. Yeah? So same as scientific research, you have to plan what your studies will be about, because you cannot cover everything. That is the nature of any studies. Our studies, any research is there is a scope. A scope means there is areas that you want to cover. You cannot cover all. So in order um, to to structure your research, you have to find out what are the things that you want to look at, what are the parameters that you want to study. Okay, and if you are dealing with samples, so how big is your samples? So if you are collecting species, animal species, which is quite common in your field as a zoologist, you might want to plan which samples, where the areas that you are looking for, okay? And you have to perhaps also plan within the samples how you're going to take the samples and how randomized your samples are in order to reduce bias, yeah? Because we want our data, our results to um, represent the studies, okay? It's not biased. Yeah? So for example, if let's say I want to do um, a survey about students at UNIMAS, maybe at our faculty at FSTS. So in order to reduce bias, bias means something like bias, unfairness lah, something like, not to say macam dia tak sekata lah, bias ni macam let's say you want to you claim that it's a survey about the students at FSTS, for example, but you just focus on one program, so it doesn't actually represent the whole faculty, because the faculty has 5 programs, so your samples ideally should cover all programs, so it will cover all sorts of levels, right? So it's not biased. But if you are focusing only one program, or maybe just 1 year, like year 1, yeah, and only zoology, and then you claim that it represents the whole faculty, so it's not fair, isn't it? It doesn't actually give the real picture about the faculty. So it's the same thing, like when you do your research, you have to reduce the bias by randomizing your samples. Yeah. So if let's say you are collecting samples in um, Kuching, maybe, yeah, maybe you can say you collect your samples from 4 or 5 places, that are randomized throughout Kuching. So that could represent Kuching rather than this topic, experimental design. So it's a topic about designing your research or your experiment. Okay, so I think I've covered why it's important. Why it is important? Because you want your data to be representative, right? So when you say at the end that it represents Sarawak, the sample, the animal or the bird species in Sarawak, you cannot go for one area only. So you should cover all. So it would give a fair overview about the whole things that you are claiming. Yeah? And then the importance is it will give you variation of the data, meaning to say that um, let's say you're collecting samples throughout Sarawak, so you can see the variation, right? And that is actually the real thing happen, the real picture. If you are just taking data from, let's say, Kuching, so might be the trend is quite similar, and it might not be true actually. Yeah, it's something to do with the bias of randomization as well. And another thing is, uh, it will convince the audience more, right? So when you say that you take the samples from a few districts in Sarawak compared to just two districts, okay? So like if I were the audience, I would be more convinced with the data, with the results that have more randomized samples, right? I mean, because that would be fair, to represent the whole area, okay? So the importance of experimental design, and another thing is in terms of the organization of the, the data. When you design the experiment, means that you would have a better plan, right, about your work. Yeah, you are not going to do something blindly. Yeah? So you have structure. Okay, first you have to do this, and then you have to do that, and you have to analyze this and that. Okay, rather than if you don't have design, design means like a plan, a structure. So if you don't have any design, you will you would go like very everything will be a mess. Yeah, so especially when you are in the lab, you should have a plan. And one of the basic practice, in the lab is to have a logbook, regardless if let's say you are not in the lab, or even though you are doing research outside the lab, you must have a logbook. A logbook. Um, you, it's a book that you write down things that you want to do for a particular day, and throughout the research period, you should have a logbook. We call it log, right? This is quite common already because you guys are trained at the school, I suppose, to prepare lab report. You put it in the logbook, right? So those are the basic practice. And in your logbook, you should write down the plan or design for certain experiments that you have, not just for the day, but for the whole period of research. Okay, so that's the importance of experimental design. It will guide, it will make the things better for the researcher and for the interpretation of the results. So what is experimental design? Okay, by definition, is a statistical design of experiments, refers to the process of planning the experiment so that appropriate data that can be analyzed by statistical methods will be collected, resulting in valid and objective conclusions. Okay, so why we relate statistics with experimental design is because some of the uh, your data needs statistics. If let's say your data are quantitative, so your data needs to be analyzed statistically. Okay, for example, the easiest example is when you collect data and you have replicates. Replicates is the repetition. Okay, and of course, if you want to present your data, uh, you need the mean value, right? The average value. You cannot present all your data and say to your audience that, okay, the data is this and this, and let's say you have 50 samples, and you're not going to tell them all the 50 values, right? You need to find one value that represent all. So the mean value, that is the easiest or the simplest statistics, yeah? The average value. And also, of course, when you talk about average values, you need to have standard deviation. Standard deviation means how is the deviation of the um, of one value to compared to the mean value. That is the standard deviation. So normally, when you present the average values or the mean values, um, let's say I want to say that the average score of statistics for the zoology program is 75, the marks. Let's say that is the average. So that represents maybe, how many of you? 100 students of zoologists, okay? So if let's say I want to present the result to the faculty after this course ends, so I cannot say, well, of course I have to give the evidence about all um, the marks of all the students who are taking the course. But if let's say I want to make it brief, what is the overall performance? So I should come up with one single value that covers all, the average, average. I'm sure that you are familiar with the concept of average. So when I say the average values, I should also say the standard deviation, ideally. So if you are presenting your data in your report as well, you should actually, ideally, it should be also accompanied with standard deviation. So normally we put standard deviation like after this symbol, plus minus. So let's say plus minus 4.2, for example. So what does it mean? This one is actually referring to standard deviation. Standard deviation. And what does it mean? It means that basically it's about, if let's say 75 minus 4 lah senang, 75 minus 4 is 71, right? 71. And 75 plus 4 is 79. Okay. So actually, it means that most of the students, or all of the students, actually got between 71 and 79, right? Okay, but the average is 75. So that is actually, it indicates the range of the students, of the score, not the students, of the score, okay, for this case. So that is meant by standard deviation, and that is how you present the data, okay. Same thing like for your case, let's say in your zoology, and so you have to find the average, you have to put the standard deviation. So in statistics, we are always concerned with the average, the mean. So that's why we are comparing the mean of one sample to another, okay. Okay, where we are. So that's the definition of the statistics. Right. So 3 categories. Preliminary design leads to future work. Oh, okay. So means that when you design your experiment, so before you do your research, before you do your experiment, you need the design in order for you to foresee what you will do in the future. Okay. So if let's say you want to have 5 samples, so you will see that the scope of your work covers 5 samples, and you can also plan how long you will do that. I mean, how you can estimate. Yeah, of course, we cannot know exactly the time, but we can estimate. Let's say one sample needs 1 month, for example. Okay, so it would lead to future work or future planning. Yeah? This is referring to the design. Yeah? And then critical design. Okay, so this one is like you want to know what kind of things that you want to measure, right? The parameter. Yeah? So if you are collecting some animal species, right? So it's not just about collecting the species, but you have to know why you want to collect the species. You want to maybe measure the diameter of the species, or what? I'm sorry, I don't have much ideas in zoology. Yeah, so there must be something that you measure. That is the parameter. Yeah? And not just measure, you have to know what's the response. Okay, for example, I give you a very easy example. I want to measure of the the height of the students. Yeah, the height of the students. So parameter is height. Responses is the output. Responses is like, of course, the height in terms of um, in centimeter, for example. So I should know what kind of things that come out from the parameter that I measure. Okay, and of course you compare from one sample to another, but you have to know the responses. So we have this term in statistics or in statistics, responses. Responses means like the output of your of the things that you measure. Okay, output. Is it everything clear? I need to make sure that from time to time it's clear and I'm not talking alone. Is it clear, guys? My voice, the slide? Guys?
Clear, Doctor.
Clear? Okay. Right, demonstrational. The responses are output. Demonstrational comparison of a new treatment with a standard. Okay, so now treatment is what we also call as samples. Yeah. So when you say that you have five treatments, means that five samples or five groups to be compared. So basically, treatment is the thing that you want to compare. Okay, things to be compared. Okay, because we are comparing the samples. Yeah? So what is meant by standard here? Standard means, okay, this one is the control experiment. Okay, so in in doing research, in conducting any experiment, you must always have a control so that you know how is the comparison looks like. Okay, so if let's say I want to compare the effectiveness of three types of fertilizer, right? Okay, fertilizer A, B, and C. I want to see how much, maybe like the height of plants that are planted with by using those fertilizer. Okay, so the treatments are, of course, there are three, but it's not just three. I need to have a control, right? I need to have a control experiment. So the control experiment is the one without fertilizer, right? So that is how I can see how much fertilizer A works. I mean, it's not just about, let's say here, let's say I'm comparing fertilizer, right? Okay, fertilizer. Okay, I have three brands that I want to compare. Okay, so the output, the parameter, okay, this one is C and another one is control. Okay, so of course I want to see how much within ABC the fertilizer performance, but also I want to see like from the control. Control is, let's say, no fertilizer. This is like a sample without fertilizer, and the rest are a sample with different fertilizer lah. Okay, so I want also to know like how much A compared to if let's say the plants are not given any fertilizer. So that will give me an idea that whether or not fertilizer A is really worth it to be used in comparison to no fertilizer case, right? So this is control. Control in any experiment, in any comparison, it must have a control so that we know our benchmark. Okay, so let's say the benchmark for the height without fertilizer is, let's say the height, let's say 10 cm without fertilizer. But if you add fertilizer A, you got like maybe 15 cm. So you know that actually um, comparing the A and the control, right? 5 cm is because of fertilizer A, something like that. Okay, maybe fertilizer B you got like 20 cm. So this one is 17. So it's very important to establish the standard or the benchmark. Okay, so normally standard is control, or it gives you like it provides you the benchmark. provides the benchmark. Benchmark is like the starting point for you to compare. Okay. Right. Okay. Design experiment. Okay. Whenever we talk about designing an experiment, yeah, so this is the process. The process is the experiment that you want to do. Okay. It must have the nature of it. Any experiment should have inputs, should have outputs. Okay. Um, Inputs, and then they must also have what we call factors. Okay. We have covered this actually indirectly. Factors are the parameter. Like in ANOVA, when we are comparing, it is stated in the problem. Yeah, what are the things that you want to compare? The factor, the parameter, or we can also say parameter. You will come across the word parameter in research as well. Okay, so whenever we want to do any experiments, we will have inputs, right? So that will be the things that we will deal with. Yeah. So without input, there is no output. So let's say you want to measure the diameter of uh, insect species, for example. So your inputs will be your insects, right? For example, insects from from many samples, right? From, let's say, 4 samples. That will be the input. So without the insects, you cannot measure the diameter, right? So that's why the inputs are important. So the factor now, let's say, it depends on what are the things that you are looking at. Okay, this one is you have to define in any research or any studies. So the parameter can be, for example, diameter of the head, maybe, of the insects, diameter of head. So that is the parameter, the things that, controllable factors. Uh, yeah. Okay, diameter of head. Okay, that is the parameter that you want to measure, right? And then what is the output? Is the result of the diameter. Okay, result. This is actually the result or the response. Wait, let me see here. Factor. Okay, right. Uncontrollable factors are the things that perhaps exist together in the process, but it is out of your control. Okay, for example, um, like if you something to do with the uh, environment. Contohnya macam you collect samples dari insects, and the uncontrollable factor is perhaps contohnya the weather, okay, maybe something like that, or maybe something about the environment, like well, if I can give an example in biotech, from biotech perspective, that's much easier. But I'm trying to imagine in your field now, like apa ya? Kalau weather lah kot macam tu. Something that you cannot control. Like for example, if you are collecting the the species, uh, weather, like rain or sunny macam tu. Ataupun okay, I hope you understand. So it's something like you can't control, but it exists in the process of during the experiment. But it doesn't give, perhaps it doesn't give that much impact on the outputs of your process. Okay. Contohnya macam mana? Nak bagi example macam mana? Okay. Kalau uncontrollable factors. Okay, let me think first. Maybe I hope that you guys understand. I don't have like any ideas in my mind now for specific examples. Okay, so basically, when you design an experiment, these are the things that you should know. You should identify. Okay, uh, inputs, outputs, right, and factors that you can control, and factors that you cannot control. Okay, for example, factors yang you can control ni macam contohnya selection of places, Okay, for your sampling. What else? Um, selection of places. Okay, maybe methods. Okay, maybe you macam standardize satu method saja untuk collect your samples. Yeah. So what I know that in zoology you will be taught on different methods to. There is a course, sampling method, if I'm not mistaken. So you would be exposed to different methods. Perhaps you can standardize or you can control only one method for all samples that you are collecting, something that you can control, something like that. Uncontrollable factors are like things that you cannot control, but it exists somehow in the process. Right. Okay. Yeah, this is just the definition of each of the term just now. Okay, so unfavorable factors are like the weather, okay, the rainfall, sunshine. Okay, maybe sunshine. Contohnya, you collect the samples. Although it's sunny, right? Maybe, but the intensity of the sunny days, you cannot control. Something like that lah. Something yang out of your control. Or maybe rainfall, hujan lebat and hujan sederhana, tapi you collect the samples. Macam tu lah. Something like that. Okay. Whereas controllable factors are things that you can control directly on your experiment. Okay. So yeah, input is materials, things that becomes the entity to be measured during your process. Okay, output is the results. For example, you're measuring the length, the weight, so that would be the output or response. Okay, I hope you understand. So factors, we have discussed about it, and levels. There are also levels within the factors. Okay, for example, if let's say your factor is let's say you want to vary temperature. Okay, you want to study the effect of temperature on bacterial growth. Effect of temperature. Temperature is your factor, but you can actually test at different temperatures. You can set the levels for the parameter that you are analyzing. Maybe you set the temperature at 20 degrees, and then 25, 30, and 35. So these are what we call levels. Okay, levels. For example, if you are doing a survey about the students, let's say whatever, macam reading habits, how many hours the students read in a week, let's say in a faculty, right? You want to set the levels. Okay, of course the parameter is the reading habits, number of hours, but you can set the levels in your survey. Let's say you put like 1 hour. Okay, how many of the students read for 1 hour in a week? How many of the students read for 5 hours? Okay, and then let's say 7 hours, or then 10 hours in a week. So these are the levels. Okay, so your data will be based on these levels. So it's not just, let's say you don't set the levels in your form, let's say your survey form, you can say that the students need to perhaps maybe letak range lah, let's say 1 to 4, okay, maybe 5 to 9, 10 to 15, 14, okay, maybe now it's 15 to 20 hours. Let's say this is level that you set for your survey about the reading habits among the students. So when you set the level like this, it will be much easier for you later when you analyze the results. You know, it's not scattered, right? You know that some students would answer this, this, and this, and this. So you don't have to organize, kind of like you have to analyze one by one. Rather than if let's say you set in the form, in the survey form, let's say you don't have the levels, the students are free to answer their the number of hours that they spend on reading. So you will see like the answers or the data that you will be analyzing will be randomized, like some answers 1 and then some answers 2 and then some answers 4. So you have to organize your data according to the levels. Okay, so that is uh, the difference of experiment that have the levels or not. So uh, actually it's much better to have the levels so that you can see the trend easily, and it's easier for you to analyze later. Okay, so that is levels. Responses, of course, the results, the outcomes. Okay, so that's the thing, the factors, levels, responses, okay, the things that you have to know. Objective of the experiment, right? So when we run any experiment, we have the factors that we want to analyze. Let's say you have more than one factors, or variables. Variables, factors, also the same, right? Yes, variables. So there are a few terms that are actually, it gives the same meaning, but they are sometimes used interchangeably, meaning to say that sometimes people use factors, sometimes use factors, variables, but basically is the thing, factors are the things that you manipulate or you can vary, so that's why it's called variable as well. Okay, so whenever we do any experiment, right, let's say we have more than one factor, yeah? So we have three factors, yeah? Let's say three factors. And let's say you are collecting species study and then you want to measure perhaps the height, okay, the weight, and also the diameter, maybe, yeah? The diameter of your apa ya? Insect lah, insects. So your input is insects. Apa insects? Beetles lah, contoh beetles. I give you like a more specific examples. So you want to measure height, weight, diameter, right? So that's the three factors. And you are collecting samples from five areas, four areas, let's say four areas. Area A, B, C, and D, okay? Meaning to say that from area A, you will take some number of beetles and you would measure all these three things. Okay. So, and of course, your main objective is to see how all of these parameters of beetles vary from area A, area B, area C, and area D. You want to see how much is the variation, how the beetles, the distribution of the beetles in terms of those parameters looks like. Okay, but at the same time, you also want to know that among all of these parameter or factors that you are analyzing, which one is which one will give you the most significant effect or the most significant variation. uh, yeah, so that is meant by the most influential on the response Y. Of course, you have three response because each of the factor would have its own response, right? So, but you want to analyze between these three factors, which one will give the most significant difference. Okay, contohnya height. You are talking about the height first. The height of beetles collected from area A, area B, area C, and area D. Is it really different, right? The height. Okay, of course you must have the average value. So that's why you have to have the average value for all the areas, right? Let's say the height is contohnya tak lah sangat kan insects. Let's say 2 cm, okay, like this. Let's say this one is 2.1 cm, the average. This is average, and then this one is maybe 1.9, and this one is 2 cm. Okay. So that is the output that you got after the end of your study, for example, the height. So course, you want to see here, does it mean you have to analyze the data statistically by looking at these average values and check whether this difference, even though it's only like 0.1, here 0.1, right? I mean 0.1 from here, and this one is like about 0.2, and this one is the same. So if you want to look all, yeah, if you want to compare all, does that 0.1 uh, make a significant change, a significant difference? Yeah? So in statistics, when we compare, when we say significant difference or not, significant difference or no significant difference, so there must be two outcomes lah. There must be two interpretation, whether the difference is significant or whether there is no significant difference. Significant means like obvious change lah, something yang terlalu obvious contohnya. Tapi dalam statistics, we must prove it by using statistical analysis like ANOVA. So it must be proven statistically. So you cannot say that, okay, this one doesn't have any significant change, but you haven't proved it statistically. You do not do any statistical tests. So you cannot do that in science, in research, okay? So in order to know whether these differences are statistically different or not, you should do the ANOVA, because in this case it's more than 2 samples, so that's why you have to do ANOVA, right? So that is actually the concern. When we want to compare, we want to know are there significant difference or not, and then it's not just that. You want to compare between all of these. Let's say this one is for the height. Okay, for the weight, of course, it has its own data, right? And let's say diameter also, it has its own data, the average values. So since let's say you do the statistical analysis, you do the ANOVA, and find out that this one doesn't have the height among all of these. They do not have significant difference actually. Although they are a difference, but tapi sikit je. Dia tak, actually, in other words, dia tak obvious sangat. Let's say 1.9 cm and 2 cm, it's not obvious, right? If you see the ruler, the scale, it's just 0.1 is actually very negligible. You can't really see it obviously, unless if let's say contohnya 2 cm and another one is 0.1 cm, that one is very obvious lah. Yeah, the difference is big. Significant difference means something is like the difference is big. Big. Contohnya macam height. 170 cm dengan 150 cm. You can see it really clearly, like even from the appearance. 20 cm really make a big difference. Tapi itu dalam, let's say, if in plain words we can say that the difference is obvious, but in statistics or in research you have to do the statistical analysis. So that's why in later when you report your results or your data, you cannot use the word significantly without doing the statistical analysis. So you have to be careful with the words, because significant difference in statistics, it really means it has been verified by the statistical test. Okay. So let's say at the end, your result is not just about comparing the height of this, but between all the parameters. Contohnya tadi height tak ada significant difference, maybe weight ada. Okay. After you do the statistical analysis, you find out that there is a significant difference between beetles from A, beetles from B, C, and D, right? So let's say W ni it gives significant difference, and diameter pula tak ada. So at the end, what you can conclude from your studies is not just about comparing the beetles' behavior from all of these areas, but also between all the parameters here, the height, the weight, and diameter. You can say that the weight is the variable that has the most influential effect on the beetles collected from all of these areas. Okay, so we also want to compare among the parameters that we want to measure, which one yang ada influential, which one that has the most, which one is the most influential, which one that gives the most significant difference. and then you boleh ni lah, I mean we can see lah, okay, the weight is, dia akan berbeza lah kepada all of these areas, whereas height actually tak ada beza sebenarnya. So that is the things that you are looking for when you do any experiment. So this is just an example for this thing, but it applies the same thing in other situations. Okay. Determine where to set the influential x so that y is almost near to the desired nominal value. Okay. Determine where to set y is small. Okay. It's something to do with the how you set the levels and so on. Okay? So basically that's the thing. Objective, we want to see the variation between samples, and we want to also see which variables or which factors, if you have more than one factors, is the most influential. Or if let's say you are analyzing only one factor, whether the factor is influential or not, whether the factor gives a significant difference or not in all the samples that you are analyzing. Okay. Right, is it clear, guys? Any questions on objectives or the slides before the design experiment? I think it's quite easy to understand, right? And also you can think logically as well. Like later, I think when you start your research, you can think it logically by yourself as well. Like, okay, you must have this, you must have that, you must plan. Planning is very important in any experiment. Okay, if there's no question, can I proceed? Hello? Are you with me?
No, doctor.
No? Okay, all right. So basic principles, right? In any experimental design, there are few principles or concepts that we practice. Perhaps you might have practiced it without you realize it, but here we just define it again. So the three important principles in any experimental designs are, first is replication, and then randomization, and blocking. Okay, so I think you have understood this indirectly before. Replication is repetition. Repetition. Or if let's say you want to collect the samples, you might not want to collect only one beetle. You might want to collect maybe at least, sebab penat-penat you pergi sampling kan, it's not just one sample. Of course you must, it's not just about you penat ambil only one je, tapi it's about the precision of the data. You want your data to be convincing. So of course you do a lot of repetitions. So in terms of the samples, is replicates lah, replication, replicates. So you must have replicates in your experiment. So the minimum amount of replicate is duplicate. Duplicate is 2, right? Only 2. But 2 might not be desirable actually. It might give you a trouble. Why I say is it might give you a trouble. Let's say you just collect 2 samples. So what happens if let's say one sample die? I mean, one sample die. One sample is the result is ni lah, tak boleh pakai. So you only have one, and you rely on only one, and it's not reliable, because in science or in research we need replicates. We need repetition, replication. Your data must be from replicates. If not, I would not trust the data from only one beetle that you measure, right? It's actually quite logical lah. So the minimum amount is duplicate, although the concept is there, duplicate, but it would not be advisable to only have 2 stuff or 2 experiments, because anything happen to one of your sample, or even maybe both of it, you don't have any more backup. So my research background is like lab based, so I don't do any sampling outside or field trip. So when I advise my students, let's say they have I'm focusing on fermentation, my background. So whenever we have this reaction, fermentation reaction, I would always ask my students to do not 2 but 3 at least. Kalau more, let's say 4, much better. So because if let's say you have 3, anything happen to one of your flasks, let's say it's contaminated in in biotech we have this kind of problems, contamination. So you can still have two samples. So two samples for you to present the data is fine. But in terms of um, the quantity of experiments, I hope you understand what I mean. So if let's say anything happened to the one sample, I can still have two, and two is better than one. Okay, if you had, let's say you have four, you got one damage, let's say one contaminated, you have three, so it's much better, right? So that's why I said is the more number of the replicates that you have, much better your results will be. Okay, much safer you will be actually, because you are not going to, let's say you have duplicates, one is not working or contaminated, or one is not can't be used. So you only have one, and of course you cannot represent your data with only one experiment like this, and you have to do things all over again. So it means a lot actually. It means a lot. The difference between having only duplicate or triplicate or more than that. Triplicate is the ideal one. Maybe we don't want to. Triplicate is ni lah, at least lah. Duplicate ni macam it will give you troubles actually. So that's why I like triplicates in doing experiment. So let's say macam fermentation kan, my field. Let's say the students have to repeat. Let's say they can't use one of it. Let's say duplicate. They have to repeat the things all over again, and the process is not easy. So why not you just invest like having one more or two more flask, macam tu kan? So you can do it like one time only. So anything happen, you can have backup. So replication is not just about giving the audience the confidence about your data, but also it's a way how you can actually make yourself safe. Safe in terms of you don't have to repeat your experiment. You don't have to do double works if things doesn't work. Yeah. Kalau let's say if you have more than duplicates, let's say you have triplicate or more than triplicate, 4 samples, but still your experiment not going, everything is a mess. Itu lain lah. That one is you have to try again. But in terms of repetition, in terms of macam you have to do it because you don't have enough samples. That one is something not desirable lah, because it will cost you time as well, not just time, energy. Yeah? Okay. So replication is very important, right? So duplicate is 2, triplicate is 3. Try is dup is 2 lah, double actually. Right. Apart from it, we also have this randomization. Okay, I talked about randomization just now, right? So especially when you are collecting samples, you must make sure that the samples that you collect represent the area that you claim it is. Like you claim Kuching, you should be across the Kuching, right? At least like few sites lah throughout, even though you cannot cover all, but it should be like randomized. And if let's say you are collecting data from students, ini yang paling senang lah. Let's say the macam tadi lah, the trend of reading habits. You cannot just focus on year 1 only. If you are claiming at the end it represents the whole faculty, right? So you should understand first your faculty ada berapa program, how many programs, and how many students, how many levels of students, right? So if you say undergraduates are those like you in doing degree, bachelor degree. Undergrad, it must consist of year 1, year 2, and year 3, or year 4, or year 5. If you are talking about postgraduates are those who are doing masters or PhD degree, right? You cannot cover. Let's say you are claiming your data is about undergrad students. So you cannot take the samples from those postgraduates, from those who are doing master or PhD. It will not be relevant. It will not be valid, right? Unless you say that reading habits among students only, students at faculty. So students can be undergraduates, students can be postgraduates. Yeah? So that could be relevant if you cover both undergrads and postgrads. Yeah? So if you are talking only undergrads, you cannot just focus on year 1 only, or year 2 only, or year 3 only. Maybe year 3 reads more. So it will not give accurate picture at the end, right? So randomization should be like randomized lah. Things should be covered all, something like that. Yeah. And randomized, like you cannot just focus on female student only, right? You should cover males as well. So it should be randomized. So that is randomization. Blocking is when you put the levels just now, or maybe like just now, if let's say you put students and then undergrad students, and you put year 1, year 2, and year 3 of all programs. So you are analyzing the students' reading habit for year 1, for um, aquatic, for chemistry, biotech, plant, and zoology across the programs. And year 2 comes to year 2 across the programs. So that is blocking. Blocking is when you put the, for example, year 2, year 1, year 2, year 3. You are, let's say, your object study nak compare among programs ada tu, among programs, uh, but you put the blocks, year 1, year 2, year 3, or male, female, something like that. Okay, so blocking is also another important concepts in experimental design. Okay, if you don't have blocking, it means that your sample will be homogeneous, will be something that is scattered, something that is macam let's say program aquatic, aquatic, and then chemistry. You don't put any levels or any blocks. Okay, this one is zoology. Okay, meaning to say that your samples ni akan ada year 1, year 2, year 3, male, female, is homogeneous, is mix up. But if let's say you put block study, year 1, year 2, year 3, okay, throughout this one, okay, it will be specific, right? So that's, and it will benefit the analysis at the end because you can see the picture much clearer. So that is the importance of blocking. So it depends also, like it's not that in all cases blocking is required. Sometimes some of the cases might not really need blocking. Okay, so it depends on your studies. But those are the three concepts in experimental design: replication, randomization, and blocking. So this is just the details. For the details, I have explained it. Yeah? Replication is to increase the scope of inference, to improve precision. Do you know what precision is? Precision, how confident you are. Let's say you measure the height of the beetles. You measure 3 times, for example. Of course, if let's say if you measure just once, perhaps you might do some errors in your first measurement. Let's say you measure twice. Measurement 1, measurement 2, measurement 3. Okay, the height at the end 2.1 cm. Okay, the next time you measure, the second time you measure 2 cm, and another one is 2 cm. Okay, so when it is precise like this, 2.1, 2, 2. Okay, so you are confident that it's actually, I mean, of course you take the average all of this, right? It would be 2 something maybe, yeah, 2 cm. So you are confident that your data is correct, your measurement is correct, because you have done it, you have repeated it. This is replication within one sample that you are analyzing. Yeah? So it's the same thing, like if let's say you take many samples, right? So it will increase the confidence about the data. Yeah, right? Of course, the errors, the variation will be there, but if you take the average values, then it will, yeah, it will normalize the average to, yeah, can represent all the things. Yeah, so it will improve the precision. So this one, like this one, is an example of precision. Precision means it's very near to each other. Kalau you ada yang main darts tu kan, you know this, the darts one. So of course your aim is to get the center, right? So if you got something like your darts macam ni, macam let's say after many points you you throw the darts, you got like very close to each other. So this is precision. We normally use this one to explain precision, accuracy, kind of things. So precision is something that is very near to each other. Okay, the data. Control the error variance. Yeah. So that's the replication. And of course, errors must be calculated when you have replication. Errors ni yang standard deviation, beza dan deviation. Randomization for reducing bias. Okay, I've talked about it. Yeah? To reduce the bias so that your data is fair. You can say it represent all. Yeah, represent the whole picture about that particular sample. Randomization ensures a valid measure of experimental error. Okay. Blocking is a technique used to increase the precision, not accuracy of an experiment. Okay, precision ni maknanya macam tadi lah, you put the block year 1, year 2, year 3, you could have a specific picture about the samples. Maybe precision macam let's say year 1, perhaps year 3 would read more, maybe because they're doing research at the end, FYP. So year 3 would spend more hours for reading. So you can see the trend accordingly. So the precision is within year 3 is ni lah. Year 3 akan macam let's say year 3 students akan let's say average is 5 to 6 hours. Most of them, let's say. Year 1 tadi maybe 1 or 2 hours. So you can see that the precision is according to the blocks that you set. Okay. Blocking involves making comparison among the condition of interest indexing within each block. Okay. So blocking also, when you set the blocking, it can like year 1, year 2, year 3. It's not just that you can compare across the treatment, like maybe you are comparing different programs, how the students in aquatic program, how the students in zoology and plant read, spend on reading. But it's not just about across the treatment, but also you can compare between year 1, year 2, and year 3 within, for example, within aquatic program, year 1, year 2, year 3, how it differs. So the comparison can occur when you have blocking. The comparison can be made across the samples, across the treatment, and also within, and also across the blocks within the treatment. Okay, let's study that. Okay, year 1, year 2, year 3. So these are blocks, right? These are blocks. And this one is, let's say, program. This is treatment. The whole thing here is treatment. Okay. So your comparison is not just between the treatments, but also between the blocks. Let's say macam we are talking about zoology program, right? You can also compare between year 1 and year 2 and year 3 within zoology program. How is the difference? How is the data vary? So that is meant by here. Okay, so those are the 3 concepts, principles in scientific or in experimental design. The guidelines for designing experiments. First, of course, you have to know what the subject matter of your research, the statement of the problem. Okay, normally the research is trying to solve problem. That is the research gap, the motivation why you do the research. Perhaps if let's say you want to analyze the morphology of the insects, beetles. Contohnya ada certain species yang rare species kan, and you want to study about it in Sarawak. Because the reason why is because it has not been studied before, and maybe the species is rare, the species is unique, and it's not similar to other species. So that is the motivation. So you have to know the problem, the reason why you do the research. Okay, so that is the very first thing that you have to know before you start or design an experiment. And then choice of factors and levels. Okay, so just now, its factors are the things that parameter or variables that you want to study. Okay, the ranges over which these factors will be varied. Okay, range is maybe you set certain range, or maybe kalau insects tu you just maybe tahu juga lah, set certain length saja, a certain diameter saja yang you want to analyze maybe. tertentu, okay? But it's something to do with the range of the factor. Okay, specific levels. Levels is within the factor tadi. Let's say maybe the height tadi kan, you set the different levels, different classes. How the factors are to be controlled at desired values, how they are measured. Okay? So some factors can be controlled, and how you want to measure the height, for example. So something to do with the methods. Selection of the response variable. Response is the output. Okay? So you must know what are the things that you measure. So when there is a parameter, there must be something that comes out, the output. Yeah? You should find out. So if let's say you are comparing three factors, you must know that you must have three outputs at the end, right? So if you only have two outputs, means your studies might not be complete. The choice of experimental design. Okay, sample size. Sample size, the number of replicates. Let's say you are analyzing different areas. So replicates tu adalah how many beetles. Let's say you want to collect from area 1. Let's say you want to collect 50 beetles, right? So that would be your sample size, because that is the size of the sample that you are analyzing. Yeah? Selection of suitable run order for the experimental trials. Okay. Determination of whether or not blocking or randomization restriction are involved. Okay. So blocking ni, you nak set macam mana? You nak put the classes within the factor, and randomization, how you're going to do the randomization. Maybe you take from different points within the sample, within the area. Okay, that is randomization. And then performing the experiment. So how you do the experiment. Okay, this is like actually the plan before. Is you have to identify before the experiment. When you do the experiment is when you are there. You are measuring, you are collecting the outputs. Yeah? And then after you perform the experiment, you got the data, right? So after this, you got the data. So let's say in the example just now, you will have the data for all the height, the weight, the diameter of all the beetles from all the samples that you collected. Yeah? Let's say you have sample A, sample B, sample C, 50 ni beetles tadi. Let's say this one is 50, and let's say this one is 49. Okay, now the sample size, it can be similar or not. Yeah? We also study about it, right? In using like Bonferroni or Tukey's method. Tukey's is when the sample size is equal. And it can be also like some cases, sample size might not be similar, which is fine as long as the difference is not that really obvious. Let's say 49, 40, okay lah, just one kan. Jangan macam kat sini 10 je. That one is uh, not really ideal lah. Kalau you as a audience pun, bila you tengok the data, of course you would feel like macam this one is not really convincing because others are 50 kan. But if let's say it's only 48, 49 tu okay lah. The difference is not that really much. So the sample size can be similar or it can not be similar. It can be not similar. Okay. Apa tadi? Data. Okay. So once you perform the data, once you perform the experiment, you have the data, meaning to say that you have all the height, the diameter, and the weight of all the 50 beetles that you collected. So meaning to say that is like this one, you have 50 lah. I mean for height, 50 for diameter, 50. I mean the data. So that is actually what we call the data that is not analyzed yet. That is what we call primary data. Primary data. Okay. Data that you measure, data that comes out directly from your measurement. Okay. So when you analyze the data, let's say you have just 50 heights, 50 heights of 50 beetles that you are analyzing from area A, for example. That is the primary data. You have to convert it into what we call secondary data, because in reporting the data, the results, if I were the audience or the one that reads your report, I don't care about the primary data that much, because I want to have what is the conclusion, what is the representative data. Okay, let's say you have 50 heights, 50 heights of 50 beetles. You must convert it into average. What is the average? That would be meaningful. That would give me an idea about the overall data of overall height of beetles collected from sample A, sample B, and C. Okay, so when you convert it into average, for example, it's not just average. It can be many things, like when you do the ANOVA test, you got the values of the F values, and you can conclude whether it's significant or not significant. So those data are secondary data. Okay. Uh, Example, it's not just average ANOVA data. Maybe you use this one is ANOVA because I have three. If you're analyzing two samples, you can use t-test. So the results comes out from all of this are called secondary data, and secondary data are the one that are reported in the report, yeah, in your thesis, for example, because those data will give uh, will make your data will make your results be meaningful. It will give us an idea about your data. Yeah? Kalau you present primary data is like when you say that 50 heights, you have 50 beetles from sample A, there are 50 heights, 50 values of diameter, 50 values of weights. If you are presenting it, so sample one, beetle one, the height is this, beetle two is this. So it's very tedious, very tedious for you, and then it's very messy, messy for us, messy for the audience to understand. So what? So the question that will come out from your primary data is this expression. So what? So apa sebenarnya? Apa sebenarnya you nak cakap? So you must actually conclude. So that is when you come up with the secondary data. Okay. So this one is via statistical analysis. So I hope that you know by right, statistical analysis or test, the importance of statistics when you analyze your data. That is to give a meaning to your data, to your raw data. This one is also called raw data. This is raw, is directly from the measurement. Okay, so that's the importance of statistics. Here is the statistics come into play. Okay, that's why we teach this topic in statistics. And from your statistical analysis, right? So that is where you make a conclusion. Yeah? Conclusion is like when you do the ANOVA test, you find out that sample A, in terms of the height, is different from sample B, but not different with sample C, for example. That is your conclusion, right? So the conclusion is based on your secondary data, because in ANOVA, you will get the F values and all this, right? And it will lead you to the decisions, right? And conclusions. So the conclusion is based on the secondary data. So that's the importance of statistical analysis, because at the end, this is the most crucial part. Yeah. That you will report that you will report in your report, in your thesis, in your abstract. So if you see the abstract, and abstract of your FYP thesis letter, abstract is a summary of everything about your research, where it must have conclusion at the end, the last two statements. It must say that what is the conclusion. Like, for example, in this case just now, the conclusion will say that maybe there is the data will be the data from area A, beetles from area A will be different from area B and C, right? And you can say also, among all of these variables or parameter, which one is actually the most influential? Maybe the weight of the beetles is the most influential factor among those factors that you are analyzing. Yeah. Okay. So that is the conclusion. And what's the importance of it? Maybe it can recommend what action to be taken. Uh, Contohnya Beatles. Okay, what perhaps it will give an idea about the studies, and it will give an insight. It's not just about the current study that you are doing, but it will give an insight to others to do the next research. Okay, maybe people have understand that like height might not be different, the diameter might not be different, maybe the weight is different. Okay, perhaps uh, the when people read your articles or your research, they might want to wonder why weight is different among the beetles. Perhaps they eat different things, or different, like different food might affect the weight, right? The weight of the beetles, something like that. Okay, so future works will um, get ideas from your work, yeah? And they would perhaps, they would come up with another research. Okay, that is recommendation. Maybe you can say your recommendation. Uh, Future studies should be carried out in order to understand why the weight is uh, the most influential effect among all the beetles in these areas, something like that. Okay, so that is the importance of the conclusion. So if you draw a wrong conclusion, and because of wrong data from wrong statistical tests, the impact um, is very contagious. It will lead to different conclusion. It will lead to different perspective from others. Okay, if let's say you tadi kan, let's say macam sepatutnya weight yang the most influential, tapi you do something wrong in your statistical analysis, you suddenly say that height is actually the most influential. So when people read your articles, and then they will lead to different direction then for their studies, or maybe height, or people believe that the height is different, so they would study other things, not the weight. Sedangkan yang sebenarnya adalah mungkin weight yang paling significant, yang paling influential. So that is why the statistical test is very, very important, because it will lead to different, it will actually affect the conclusion, and also the perspective of others about your studies. Okay, so that is the guidelines. Is it experimentation? Apa ni? Formulate hypothesis. Okay, so experimentation, actually the basic things after this ni lah, after ni conclusion recommendation, but this is just additional stuff. So you must know your hypothesis, right? Okay, in any work, before you do the work, you must have the hypothesis. You must know your hypothesis. So for example, we study in statistics, right? We study two types of hypothesis: alternative and null hypothesis. So in terms of the, let's say, height, you would say that the null hypothesis, there is no difference of height, no significant difference of height of the beetles collected from sample A, B, and C, right? But the alternative hypothesis, you believe that there is a difference, right? So actually, the weightage is more to alternative hypothesis. I mean, how to say that? It's because of the alternative hypothesis that you do the research. In any research, it's because of the alternative hypothesis, because we believe that there is a difference. We actually like we know that we expect that there is a difference. That's why we do the experiments. Um, yeah. Okay. Macam contohnya kan, I do the simple survey, reading habits among the programs. I do believe that there is a difference. It must not be the same. It must not be the same, because in anything, there is no something that are similar. Something that macam I can say that students in program A, students in aquatic program, zoology and plant will spend 5 hours. All of them will spend 5 hours in reading. It's something that is not really the case, right? So that's why null hypothesis is not as strong as alternative hypothesis. Okay, I hope you understand what I mean. it is actually the alternative hypothesis that drive any research to be done, because we believe that there is a difference, there is a something that is not similar. Okay. So in short, you have to know the hypothesis of your work, and it's actually it's very easy for you to formulate, to understand your hypothesis if you know what is your aim, what is the objective of your research. Okay, so objective and the hypothesis of the experiment is it is very close. So it always comes after each other. Successful experiment, okay, this one is like after you apply all these the principles that I've mentioned just now, yeah, that will determine, that will contribute to the successfulness of the experiment. Yeah, when you have a proper plan, you know what are the factors that you are analyzing. You're not like analyzing blindly. Yeah? For example, just now, if you take the samples and beetles, and you know that you want to analyze height, diameter, weight, rather than if let's say you don't have plans, you just collect the beetles, but you do not know what to do with the beetles. So it's such a waste, right? So it's very important to have the plan, to know what you are looking for. Yeah. So this one is all the answers to what we have discussed before. Summary: use statistical techniques. Yeah, I've mentioned the importance of the statistical analysis. So that's why we teach you guys in year one, in order to give you the exposure on statistical tests, so that you know what to do with your data once you get the data. Okay, so this one is just right. Okay, I think it's just the summary of what I think I have covered indirectly. Okay, you can read by yourself. Right, so that is the first lecture. Any question about experimental design? Okay, you should know what is experimental design, the importance of it. Okay, what are the things that you have to know about doing experiment, the process, which is the experiment, the inputs, the outputs, controllable factors, uncontrollable factors. Okay, and for the factors, you must know that you can set levels, right, or blocks, and you have to apply replication, difference. Yeah? And then talk about these three principles: replication, randomization, blocking. Okay, right, the guidelines. Okay, what are the things that you need to set in your experiment until you get the conclusion and recommendation. Okay, I think that's it. I have two more slides, or two more lectures, but it's not that really long, each of that. Okay, can I end for this one and move to the second part? Is it okay, guys? Okay, can we move to the second part? Hello?
Can, Doctor.
Can?
Yes. Okay,
Okay.
Doctor.
All right. So the second topic is what we call completely randomized design. So it might be new to you, but actually it's not. It's what we have covered in ANOVA. But here we just see the rationale of one-way ANOVA. Okay. Right. Just keep it first. This term, completely randomized design. What is all about? Okay. Okay. Let me give you an example directly. Okay. Uh, is the simplest of all experimental designs. Is a sample of homogeneous experimental units. Quantity is thoroughly mixed and then divided into small lots. And okay, dia macam ni je. This one is actually referring to one-way ANOVA. One-way ANOVA is when you have samples, right? For you to view it clearly, yeah? Because if you go word by word, maybe you can't see the things, visualize the things. So I give you an example directly. So when you have one-way ANOVA, this is without blocks. So meaning to say that the samples here is homogeneous. Yeah? Let's say sample A, sample B, sample C. So the whole thing here, what we call completely randomized. Each of this is actually what we call completely randomized. Why? Because you don't have blocks, right? Let's say you are taking the data from students, the reading habits. Uh, I just randomize my data collection. Okay, maybe um, randomize macam I ambil some from here, some from here, some from other programs, some from year one, some from year two, randomize. Yeah? So the whole data is randomized. That is what we call ni lah, homogeneous. Homogeneous. Because I don't set any blocks. So the whole thing, 50 data or 50 data from 50 students, I call it homogeneous because I just take it randomly. Yeah? So the nature is homogeneous. Okay, so it's called this kind of things when you have one sample and you completely randomize the collection of the data within each of the sample that you are analyzing, that is called ni lah CRD ni, completely randomized design, because you don't set any blocks. And it's the simplest because yeah, you don't have to set the blocks. You don't have later we have a CRBD, completely randomized block design. That one is with the blocks. Okay, so this one is randomized within the samples. Okay, so basically is the thing is here lah actually. So here is some information about the advantages, right? So it's easy, right? Easy to conduct actually. Macam dia tak, kalau you let's say macam if you put the blocks year 1, year 2, year 3, although it will benefit you at the end, tapi it will complicate you in terms of when you collect the data. You must focus on year 1, year 2, year 3. Yeah, I know that it's organized, but uh, in terms of the conduction tu dia lagi is actually more tedious compared to if let's say you just randomize, you take any data. Okay, right. That's why this one is claimed to be easy, yeah, to be done. Yeah? The design is easy to analyze even though sample sizes might not be the same for each treatment. Okay, so easy to analyze because you're just taking everything all together. You're not analyzing based on things. Yeah, that is meant by easy to analyze. It can be used for any number of treatments. Okay, so if let's say you have more than even 3, 4, and 5, yeah, if you randomize within it, yeah, it is applicable. This kind of practice, this kind of design. Number of replicate can vary from one treatment to the another. This one, yeah. So it means that the sample size you can have 15, 49, or maybe 48. It's fine. It doesn't matter. But if you contohnya certain things, tak apa, later we go for the blocks one. Okay. Loss of information due to missing data is small relative to losses with others. Okay, so those are the advantages. So the disadvantages, okay, so here, any extraneous sources of variability will tend to inflate the error term, making it difficult to detect differences among the treatment means. Okay, walaupun dia nampak macam simple uh, in terms of the execution, okay, like you randomize the collection of the data, but still it is difficult to detect differences, like macam Contohnya macam ada, let's say ada difference, but you do not know actually it reflects to what, because your data is randomized. Unlike if let's say you have year 1, year 2, year 3, let's say you can see the difference clearly. Okay, maybe year 1 have difference, year 2 have no difference macam tu. But with the randomized design, when everything is homogeneous, you cannot detect the difference fall into what level. Okay, so itu dia punya disadvantage lah, although it's easier to be conducted. Okay, so that is meant by this statement over here. Okay, this one randomize. Randomization is you randomize. So this one is how you actually select your data. I'm not going to do on that, but I'm going to focus on sekejap ya. Let's go to the hypothesis first. So the hypothesis is very easy lah, because you are just comparing the samples. So you must say that this one, these two kind of hypothesis. That's why I said this one we have covered in ANOVA, but it's just to see the rationale of it. So these are the hypotheses that you have to set, and because you are analyzing samples only, not the blocks, there's no levels within the samples, so you are comparing all together. Every sample ni semua sekali together compared to another sample. Okay, so that is meant by here. And then the variation. Okay, the variation. There are two types of variation. Right, the first one is assignable variation, which is due to the treatments. Okay, the variation within the treatment. Okay, macam mana sample A, contoh sample 1 differs from sample B and sample C. That is between or due to the treatments. Another one is variation within the treatment. Okay, now you have like sample size, right? Let's say here is 50. So the variation within the data, the variation of the data within each of this treatment is what we call error. So that's why when we create the ANOVA table, so we have the variation of due to the treatment, variation due to the error, variation due to the blocks when we have the blocks. Okay, so just to say to you that the variation, it can happen within the treatment and within the sample. Okay, within each of these sample, there are the variation juga. It's about replication kan, because when we collect the replication, it's because we want to increase the precision. We want to have more data in order to have a general view. Okay, but the variation among those data is actually called error, like experimental error. Okay, that is what we term as unassignable variation, something that unassignable. In other words, yang lebih penting adalah the errors between the treatments lah. Okay? Error ni macam ni, macam kalau you measure kan 2-3 kali, you want to make sure that your data is confirmed. Same thing lah macam ni. You take the 50 samples because you want to make sure that samples are enough to represent sample A. So the variation is because of the experimental errors. Alright, so this one we have covered. Tapi dia balik kat sini. Okay, so the most important thing is this one. Yeah. So linear additive models. Okay, so you have, you know now already what is the output or response. Okay, so when we have a very simple example, when we have studied like the linear equation kan, masa form 5 pun dah study kan, linear equation when you have y, x, and you have this standard equation mx plus c, is it? So m is the slope, right? X is the x variable ni, y is this one, c is the intercept. Okay, so what is actually the meaning of this equation? What is the meaning of this equation? Apa sebenarnya? What do you understand from this linear equation. So later on, the M and C ni dia akan jadi variable. It depends on the case. It depends on the data that you have. So it will be numbers lah. Actually, let's say I give an example of equation, linear equation. 2x plus, let's say 3. So when you say y and x ni, it's actually a relationship, kan? A relationship. How much x will be how much this one portion ni akan jadi y. Or in other words, you can say y is actually the response. The response. So I'm trying to relate with here. So in any data that you are analyzing, if let's say you want to see how much the response is influenced by the factors, okay? Contohnya macam tadi kita cakap pasal apa ya? Okay, a very simple example reading habits. Okay, reading habits. Okay, now why let's say our response is number of hours students read. Okay, number of reading. That is the parameter or response. And the parameter can be you boleh analyze different faculties or different programs, or maybe between male and female, kan? So it can be varies lah. Okay, let's say different faculties. Different faculties. Okay. So when you have the data, like you have a complete data and you analyze it, and in statistics also, besides having those information about the average, the ANOVA results and so on, you can also model the data. So what is meant by model is to create, this one is to find a relationship. To find a relationship by creating an equation. Models are actually also called equations. In mathematics, the models are equations. So if you have like just now, this one, linear models. Let's say a very simple model yang you dah biasa is y equal to mx plus c. Let's say this one is the general form, kan? But if let's say you have certain data, right, and you fix it, okay, you model your data, after ni you dapat, let's say y equal to 2x plus 3. This one is because of you based on data that you are analyzing, right? Based on data. So this is example of linear. Sebenarnya linear sebab models ni dia ada banyak type lah. It can be quadratic model, graph ni. This one linear. When we say linear, it's something that is straight line. This is linear. Okay, this is linear. Quadratic macam tu lah. Ataupun side model, what's the name? Side model, something like macam tu. Dia ada macam-macam bentuk of graph, right? But now we are focusing only the easiest one, which is the linear. So the linear here, the y, x. Itu yang paling senang. So what does this equation means? All this while we know that this is equation kan. Tapi apa sebenarnya equation ni? What is this equation all about? What does it mean? It shows to you that how y is always the response, how it is affected by x. X is the factors that we normally control. Okay, so it means that y equal to 2x plus 3. So that is how y is described. That is how y is correlated with x. In this case lah. But if let's say you have your own data, this is just an example. It's not the fixed values. But that is what the models or equation means. It is a relationship between y which is the response, and x, y is the response, and x is the factor that you control or you analyze in your experiment. Okay, right. The same thing. If let's say you have this one just now, if you have like you are analyzing different samples and you have the factor and you know what's the response that you're looking at the end you can, based on your data, you can create model. This is model. Yeah, model is equation that can give the idea about uh, your data lah. Okay. So contohnya macam ni lah. Macam this one, T is what? T is the parameter that measures the effect of observation, the factor that you are analyzing. Y is the response, the response, the observed value that comes out, the output. So what else the rest? The rest are variables, or mu here is the mean, overall mean. Okay. So since we are here, we are talking about mean. The EIJ is the error. Okay. So this is just to show to you that at the end, the response can be related, can be correlated with the factors and all these errors in terms of the equation or linear, in terms of the mathematical model. So this one we call model. Model. Okay, maybe you tak nampak lagi, tapi perhaps later when you have your data, yeah, I mean your research data, you can discuss with your supervisor, yeah, what you should do more apart from concluding either significant or not significant from the ANOVA test. This is actually an extension, yeah, another thing that you can do with your data. Modeling, we call it modeling. Is a subject in statistics or in maths. Modeling. The modeling is a process of creating this one, creating equation in order to give a picture about how much the relationship between the response and the factors in your studies. Okay, right. I hope that that's clear to you. Okay, I'm trying to just emphasize on the important points. So that is models. Yeah, the ANOVA, of course, we have studied before, but that one is dia yang extension version will be the modeling tu lah. Modeling tu adalah the advanced kind of analysis. Yeah? Sometimes maybe most of the analysis would end sampai ANOVA saja, because we just want to know what is the conclusion, what is the variables that give difference and what is not, right? But the modeling, the importance of it, it will give an overview about, it will be very important for forecasting. Normally, if let's say, I'm not sure about zoology, please forgive me for that, but if let's say in biotech, for fermentation, let's say, if let's say we know that how the modeling equation, the model equation looks like, we can perhaps plan or predict, like let's say maybe if let's say we increase this kind of parameter to certain level, okay, it will have more or something based on that equation. So it helps, in short, it can help the prediction of, it can help the researcher to forecast future kind of experiments. That's the importance of modeling. Okay. Macam if let's say you are given any equation, right? So if let's say y equal to 2x plus 3. So what happened if let's say your data is between x, mesti ada range juga. The x is like between, the data is based on data between 1 and 10. Okay, let's say lah. And let's say you want to predict what happened if let's say the x is 12 maybe. So you can use the equation to find what's the y values, right? Let's say your data is here, but you can use the equation that you built, okay, providing that the trend is linear. Yeah? You can predict, let's say when x is equal to 12, what happened to the y. So it helps in predicting, in forecasting the points beyond the data actually. Okay, so that's the importance of models, and that is completely randomized design is all about. Okay, right. Okay, any question on this? Okay, I just move to the last part, just to finish the things. The third part will be completely randomized block design. So you can see the additional point here is the block. So we have studied this before again, but just to give you some more detailed description, right? Okay, this one is the difference is only the block, okay? Addition of blocks. Okay. So macam ni lah. Yang tadi tu tak ada blocks. So this one is sample. You have sample A, B and C. Okay. So in the previous topic dia tak ada block, tak ada level, but here let's say we introduce blocks. So that is the difference lah. Okay. So let's say in terms of students yang paling senang lah, year 1, year 2, year 3. So these are the blocks. Okay. So again, let me introduce again. The blocks is used. The blocks is a similar homogeneous experimental units. Okay, you can see that the blocks, it has levels as well. If you want to put year 1, year 2, year 3, again, let's say you put like male or female, so there are 2. Right? So you can actually create the level of within the blocks. Okay, right. So what is meant by completely randomized block design? Although you have the blocks like year 1, sample A, but within this one, within this scope, you have to randomize as well. Contohnya A tadi program aquatic and year 1. So year 1 students in aquatic program, so you also have to randomize. Maknanya macam you collect the data randomly from year 1 aquatic program. Okay, meaning to say that you are not taking the samples or the data just from certain students, like only students in one class. Maybe like year 1 and aquatic there are many groups, let's say 3 groups. So you randomize between that, but within the scope of year 1 and program, whatsoever program that you are focusing on. Okay, so the randomization occurs within this scope. Okay, so the difference between this one, the block design, completely randomized block design, with the one just now you don't have blocks, so you randomize within all the programs. Macam contohnya program aquatic, so you randomize the collection of the data within all the students in aquatic program, but you don't have any blocks. But this one you have the blocks, means that you are more specific. Okay, so that is completely randomized block design. It's actually to introduce the design is called like that, but actually you have studied this before when we study the one-way ANOVA with blocking. Okay, right. The variables. Okay, now because you have treatment is the samples, and you have the blocks. So the variation, when you have the data, of course you have more than one data. Let's say then, the variation, it can happen within the blocks, like within year 1 across the treatment, or between the treatments. Yeah, so that's the variation. Variation due to the block and variation due to the treatments. Okay, like let's say you are talking about faculty program A, within, due to the blocks, you can see that from year 1, year 2, year 3, within A, how much the variation. Okay, and you can also see the variation between the whole thing here, A, B and C. Okay, so that's the variation that can occur, and that's called assignable variation. Okay, I think that's it here. Cases when blocking is used. Okay, so how you can know whether you need the blocks or not, it depends on the case. It is pretty much case dependent. I cannot say that all cases in zoology needs blocks. I cannot say that, but it depends on the cases. Okay, sometimes the blocks are needed, or sometimes they are not necessary. So these are examples of cases when blocking is used. Okay, subdivision of a field of crop, litters of animals. Okay, it's very case dependent, like I cannot really generalize this kind of cases. Okay, right. Statistical analysis. Okay, before this you have studied that when there is a block, we have to also consider kind of additional stuff, right? Treatment. Yeah. But first thing first, when you are given any example of, let me give you an example of problem. Right, this one. First thing first, the most important for you to identify is the sample, the treatment. That will give you an idea about the blocks. Okay, contohnya macam ni ya. An experiment was conducted to compare the effects of 3 different insecticides on a particular variety of string beans. Okay. So the main objective here is to compare the 3 insecticides, right? So this is treatment. You will know directly that that is the treatment or the samples and not the blocks, because one of the common mistakes done by students is the wrong identification of blocks and treatments. Yeah, when you are given like maybe like this data only, without you analyze the problems, the words or the statements, you might be wrong. You might be label this one as treatment and this one as blocks, which is not the case. That's why you have to understand um, the problem, because sometimes the treatment might not necessarily be the rows. This is rows, right? This one is this one is column. Sorry, this one is column. This one is rows. What I mean is like this one. Let me add a row, right? So it's not necessarily that treatment. The blocks are in rows and the treatments are. It can change. It can be changed. But the most important thing is you have to identify from the problems what is the first thing that is to be compared. The main uh, thing to be compared. The main thing to be compared, which is it should be treatment first or samples first. Yeah? So once you identify that, okay, once you know that insecticides are treatments, and of course you know that the blocks are blocks, and this one is blocks. Okay? So that is in terms of the identification of treatments and blocks. Okay, let's go back here. Okay, so now let's just jump directly to the linear model. Okay, um, so again for this one, there it has its own way how to construct the models or equation. Yeah. So here, just now in the completely randomized design, we only have treatment, right? So here, of course, we have to insert also the blocks, right? The block effect, because the response now, this is the response, it will be uh, influenced by both the treatments and the blocks. Yeah, both of them, both of the treatment and blocks give effect to the response or to the results. So that's why those things need to be considered into the linear equation model. Okay, right. The rest of it, in this LU4 ni, we're not going to ask you calculation, but we hope you guys will understand the concepts, macam what's the models, what should be included in the models of completely randomized block design, and what's the difference between the models in this design with the completely randomized design. So you just understand the concepts. Because this one, all this TSS and SST, we have taught you how to do this in the previous LU. So that's why this is just a revision. Okay, so this one is the example of data. Okay, and for, let me, this one is, I think is PowerPoint file. Let me open the PDF. Some of the images are not there. Hold on. Oh, okay. So this one is better. Right. This one is the linear model. Yeah. So this is it. It has the same pattern actually. This one is the overall grand mean. The last term here is the error, which is the same as the CRD, but the additional part is the block effect. Yeah? The block effect. Right. For the hypothesis, okay, I've mentioned in the previous topic, for when you have the block, you must also consider the hypothesis for the blocks, not just for the treatment. Okay, so like this one is for the treatment. Let me see this. Okay, okay. Let me explain here. Okay, so because of these two effects, okay. So hypothesis. There are hypotheses, two sets of hypotheses, not two hypotheses, two sets of hypotheses. H1, and this one is for the treatment, and this one is for the block. Okay, because we are analyzing both. So the alternative, the null hypothesis for the treatment, there is no difference of all the mean of the treatments. Okay, alternative adalah there is a difference, but for this one, there is no difference of the means between the blocks, right? Between the blocks and this one, there is a difference. So just to say that there must be two sets of hypotheses when there are blocks, because the blocks need to be compact as well. Okay. Advantages. Okay, let's see the advantages. Useful design for comparing treatment means in the presence of single extraneous sources of variability blocks. Yeah, of course, it makes the data looks more specific, yeah, compared to just randomized kan. But the block tu lagi ni lah, dia lagi specific. Yeah. Simple, easy to construct. That one is yang tadi pun easy juga kan, tapi it depends on your objective sebenarnya. Like this one, if let's say you want specific results, then you need the blocks lah. Yeah? So the easy or not easy to, it depends on your needs first. That's what I can say lah. Disadvantages. Okay. The design will not be suitable if there is interaction between block and treatment. If let's say, that's why I say is some of the cases might not need the blocks. Maybe macam you are collecting samples and I think macam collecting samples tu tak perlu blocks sangat. Kalau yang macam let's say yang simple research, simple survey yang perlu ada year 1, year 2, year 3 tu, that one maybe depends lah. Kalau your objective is to see the levels, the trend of the year, maybe you need the blocks. If let's say that's not your objective, maybe you don't need the blocks. So it's pretty much depends on your objective. Okay, so whether you need the block or not. And what I can say, the advantages in general, it will give you a very clear overview about your data because you have specific classes, not just randomized data. Macam tadi randomize the whole sample, right? But the disadvantages, I can say, some of the cases might not be suitable or might not be necessary to have the blocks. Yeah. So in that case, if let's say you conduct juga blocks, it might be complicated or it might be laborious, right? And also it will be ni lah, in terms of the conduction tu dia lagi leceh lah, sebab you ada banyak benda yang you nak cover. I mean, you have to focus rather than if you have randomized kind of data. Okay, that's what I can say. So some of the points here are quite subjective. I cannot really agree with it. Like easy to construct. It depends on your objective. You must know your objective first, like in any experiment, before you decide whether or not you want to have the blocks or whether you just want to conduct completely randomized design. Okay, right? I hope that that's clear. Example ni tak ada apa sangat actually. It's just to give you overview about how the blocks are, but it doesn't need you to, because the calculation you have studied it in the previous topic. So I hope you understand these two kind of concepts. Yeah, the last two part that we discussed just now, CRD and CRPD, right? It's just a recap about ANOVA, one-way ANOVA for CRD, and one-way ANOVA with blocking for this one. Just to talk about the design, okay, the rationale of it, right? And the most important thing is this one, the linear model. So you have to understand, right, for this one, the response is also affected by the blocks, not just the treatment. Okay? Right, so that's it for LU4, and we have finished all the LUs actually, because we only have up to LU4. So we have covered LU1 until 4, right? So, any question, guys?
Doctor,
Yes?
I have not scanned the QR code.
Oh, okay. So, sorry, let me. So for the lectures, I have finished all, so there's no more lecture after this. But I have posted the date for the presentation of LU3 tutorial, right? Next week. So during the class time, hold on, I need to share the screen. Okay. Yes, because the exam date I don't have yet, but it's gonna be the end of the final exam date. It could be end of this month. I mean, we already start the exam week by end of this month, but I'm not sure yet about the date for statistics. I'll update later. But we're gonna have that final exam very soon, so that's why I make the presentation for LU3 tutorial, because LU3 is quite a long and important topic, so that's why I need you guys to understand very clearly. So we're gonna have the presentation as assigned, yeah, next week on the 11th of January. So you guys are clear with the instruction, right? So all of you have to submit like usual by group the soft copy of your tutorials, but for the presentation, you guys have to present according to the questions that I have assigned. I posted on Telegram.
Okay, Doctor.
Right? It's clear, right? Group 1
Yeah.
will present question 1. Group 2 and 3 present question 2. Question 4, group 4 and 5, question 3. Group 6, question 4. And group 7 and 8, question 5 from the tutorial given to you. Okay, perhaps you discuss, but maybe all of you in a group have to try the questions by yourself, because that will benefit you in your exam later. But then you can compare. If let's say your answer is different, then you can perhaps discuss why it's different, right? That's the way how you discuss in the group. And for the oral presentation, I expect maybe one or two of you represent the group, will present, right? You just show your workout. You might have written it on the paper, right? So you scan it nicely, make sure it's clear, and you scan it. And on the day of the presentation next week, you just share the screen and explain to your friends how you get the answers. Okay, so that will help you because you need to understand the ANOVA very very well. Yeah, because it's a long methods from the ANOVA and then goes to Tukey test, Bonferroni, and how you select Bonferroni, how you select Tukey test. That's important because uh, that requires understanding about the problems. So I need you guys to learn from each other, and I will check direct. Is it clear for you for tutorial 3 what you have to do next week?
Yes, doctor.
Right. And other than that, if let's say you need more exercises, you can find the extra exercises on the internet. Just Google the topic, let's say Bonferroni methods. You can find the questions, a lot of questions on internet. And if you are not clear, you can ask me. But I might not be able to find all the extra questions for you. Yeah? So that one you have to put some more efforts for your own exercise, for your own practice. Same goes for the LU2. Yeah. For LU4, this one you need to understand the concepts. The doesn't require you to calculate, but you have to understand the concepts, all those experimental design concepts, CRD, CRBD. Yeah. Okay, any question before we disperse? I will brief more about the format of the final exam later on once I get the confirmation about the papers, also the date. Okay, I put on ELIP already, all those tutorial 4 as well. Okay, you can have a look at the tutorial 4, or you can have a look by yourself later. On ELIP, I put it, right, tutorial 4, and the deadline is, I think it's 18 December, sorry, 18 January. Yeah, I think 18 January, because tutorial 4 is not that really much. You'll be given articles. You have to choose article 1 or article 2, and you have to answer or identify things from the article, some of the parameters or things that I asked in the questions. So it's about identification of the points from the articles. Yeah? So the deadline is 18 December for tutorial 4. I put it on ELIP. Okay, so please have a look at those tutorials. Right, so if there's no more questions, so
Doctor,
yes.
Doctor, can I know is that submission for the tutorial 4 is 23 or 18? Because I see in another section it's put 23, if I'm not mistaken.
Hold on, yeah. Date is the old date that I put before in the last semester. Where did you say 23rd?
20 something, 20 something.
Okay. It's on 18 January. That's for sure. 18 January, because you're gonna have final exam soon, so that's why I make it like very soon. Okay, so can you see the screen? Yeah, now?
Yes, Doctor, yes.
Yeah, so you can see tutorial 4 here. Tutorial 4. I don't put the deadline, is it? I don't put it. But it's on 18, the deadline. You have to submit on by 18.
Okay,
Or
Doc.
is it soon? Okay, 18, yes. Okay, guys, if there's no more, I will disperse the class here. Okay. So for those who are not able to join today's lecture, I will post the recorded lecture. I always post the recorded lecture on eLib. I hope you realize that. You can just play it again if you want to have a look at the things that we have discussed in class. Yeah, I'll put somewhere in later. Yeah. Okay, guys, any more before we disperse?
No, Doctor.
No? Okay. Thank you very much for your attention. I'll see you guys next week. Okay.
Thank you, Doctor.
All right.
Thank you, doctor.
Welcome.
Okay, Doctor.
Okay. Welcome.